Today, we're diving into something you probably remember from school, but I promise, we're going to look at it in a whole new light. We're talking about the Pythagorean theorem. You know s squared plus b squared equals c squared. It's one of the most famous equations in all of mathematics. But have you ever stopped to think about just how old this idea is? And why it is so much more than just a formula for finding the side of a triangle? Let's start with the man himself, Pythagoras of Samos. He was an ancient Greek mathematician and philosopher who lived over 2,500 years ago. He founded a school in what is now southern Italy, where he and his followers, the Pythagoreans, explored math, music, and the nature of reality. To them, numbers weren't just for counting, they were the building blocks of the entire universe. And the theorem that bears his name was a cornerstone of their philosophy. The theorem is elegantly simple. It applies to any right-angled triangle. Those are the triangles with one perfect 90-degree corner, like the corner of a book or a screen. The two sides that form that right angle are called the legs, which we label A and B. The longest side, opposite the right angle, is called the hypotenuse, which we label C. The theorem states that if you square the lengths of the two legs and add them together, the result will always equal the square of the length of the hypotenuse, a al cuadrado, más b al cuadrado igual a c al cuadrado. So, if you have a right triangle with legs of length 3 and 4, what's the hypotenuse? Well, 3 squared is 9, and 4 squared is 16. Add them together, and you get 25. The square root of 25 is 5, so the hypotenuse is 5. This 3-4-5 combination is the most famous example, known as a Pythagorean triple. There are infinitely many of these whole number solutions, like the 12th of May 13 or August 15th 17. It's a perfect, predictable relationship. But here's a fascinating twist. While Pythagoras gets all the credit, the concept itself is much, much older. We have evidence from ancient civilizations that predates Pythagoras by over 1,000 years. Archaeologists have found Babylonian clay tablets, like the famous Plimpton 322, which list columns of numbers that represent Pythagorean triples. These tablets date back to around 1800 BC. This means that long before the Greeks, people in Mesopotamia knew about this special relationship in right triangles, and were using it for practical purposes, likely in construction, land surveying, and astronomy. They might not have written it as a formal theorem, but they definitely understood the principle. So, why is it named after Pythagoras? Well, it's believed that he or his school was the first to create a formal logical proof for the theorem. They didn't just know it worked. They proved why it works, for all right triangles. They transformed it from a useful rule of thumb into a universal mathematical law. That's a huge leap in thinking, and it's a big part of why his name is attached to it forever. The elegance of the theorem can be seen visually. Imagine drawing a square on each side of a right triangle. The area of the square on leg A would be the area of the square on leg B would be b squared, and the area of the big square on the hypotenuse C would be c squared. The theorem tells us that the areas of the two smaller squares perfectly add up to the area of the largest square. It's not just an equation. It's a beautiful geometric truth. There are hundreds of different visual proofs for this. Some are incredibly clever and simple, showing how you can literally cut up the two smaller squares and rearrange the pieces to perfectly fit inside the larger one. The impact of this theorem is impossible to overstate. It's the foundation of trigonometry. It's crucial for navigation, telling us the shortest distance between 2 points, which is a straight line. Think about how GPS works. It uses signals from satellites to calculate distances, and those calculations rely on these fundamental geometric principles. Engineers use it to design buildings, bridges, and roller coasters, ensuring structural stability. Animators and game developers use it to calculate paths and movements in virtual worlds. Even something as simple as figuring out what size ladder you need to reach a window involves a quick mental check of the Pythagorean theorem. It's a perfect example of how a simple mathematical idea, discovered thousands of years ago, remains one of the most useful and powerful tools we have today. From ancient land surveyors to modern space exploration, s squared plus b squared equals c squared has been there, quietly shaping our world. It's a timeless piece of human knowledge, connecting us all the way back to the dawn of civilization. So next time you see a right angle, take a moment to appreciate the beautiful, ancient relationship hidden within it. Thanks so much for watching. See you in the next one.